Good evening, everyone. I hope all of you are doing good. Welcome to Cambridge Guru once again. And today I have come up with a very interesting and exciting question of AP calculus. AP meaning Advanced Placement Calculus. And if you are watching this video and if you have opened the thumbnail, that means you know what is AP, right? And this question came up in 2021 question paper without using the calculator. So let's see what this question says. It says that let f be a continuous function defined on the closed interval -4 to 6. The graph of f consisting of 4 line segments. This is the graph of f which is shown. Let g be the function defined by the integral of this function fx from 0 to x. So from this information, what we can deduce is that the gx is the integral of fx, or I can say that this fx is basically the derivative of gx, because if we integrate fx, you will get the gx. So our parent function is gx, its derivative is fx, right? Now question says, on what open intervals is the graph of g concave up? So graph of g concave up meaning we need to find out the concavity of g function, gx function. Now in order to find out the concavity, as you must be knowing that concavity is related to the double derivative of any function, meaning we need to find out the double derivative of g, right? Now we have g, we have its derivative which is fx, right? And if I again differentiate this function, meaning if I differentiate this double derivative of g double dash x, I will get the derivative of fx. Now remember that concavity meaning if the double derivative of any function is positive, if double derivative is positive, if d2y by dx2 is positive, we say that it is concave up, right? It is concave up, and vice versa. If it is negative, it is concave down. Meaning we need to find out the sign of g double dash x. In other words, we need to find out the sign of gradient of f, which is f dash x. Now we have the graph of fx shown. If we look the intervals where the gradient of f is positive, f dash x is positive, basically we need to find out g double dash x. For concave up or concave down, concave up basically we need to find out. So it means that we need to find out the intervals where f dash x is positive, okay, meaning the gradient is positive. So as you can see in the figure, from -4 to 2, this gradient is positive. Okay, this is positive. So one interval I have found out from -4 to 2, -4 and -2, sorry. And second interval is from 2 to 6. Okay, here also the gradient is positive, meaning function is rising, right? So again, so union, I will write this answer like this, which is 2 comma 6, and 2 and 6 are on what open interval it says, because obviously we need to talk about the open intervals, because at the corner point function is not differentiable. So this needs to be put up with open brackets. Okay, this is your answer, because we cannot tell exactly that the function will be derivative at the corner point -4. Okay, so this is your A part. Next part says that let p be the function defined by px equal to gx dot fx. Find p dash 3. So now another function is defined by the combination of gx and px. So basically, if we have to find out p dash 3, meaning we need to differentiate this p dash x, px, right, which is p dash x. So applying the product rule, okay, if we need to find out p dash 3, we have to evaluate p dash x. For that, there is a product rule which says that differentiate first function, which is g dash x, into fx, plus differentiate the second function f dash x into gx. Okay, now if we say that gx according to the definition is the integral of fx, and in the A part we have evaluated, we have deduced that basically g dash x is fx. Okay, so this term is basically fx multiplied by fx, right? So I can replace this as fx into fx, which is fx whole square, plus f dash x into gx. Right? Now, for p dash 3, at x equal to 3, we can easily find out f3, right? Okay, so if we need to find out p dash 3, meaning it is f3 into f3 plus f dash 3 into g3. Okay, now look at the graph. In the graph, f3 meaning the value of the function at point 3, this is our point 3. Okay, this is point 3. So value of the function at point 3 is minus 3. So this basically is minus 3 into minus 3 plus f dash 3 into g3. Okay, right? So this is 9 plus something. Okay, now this g3 and f dash 3 we need to evaluate, because in the this is the graph of function, we cannot evaluate exactly the value of g3, right? But f dash 3 also we can evaluate from the graph. Okay, what is f dash 3? As we know that f dash is basically the gradient of the function, and here this is a special case that from 2 to 6, meaning at x equal to 3, the gradient is 1. How I can say this? Because from 2 to 6, the function is a straight line, and within any straight line, within every point between the straight line, the gradient will remain constant. So the gradient of the straight line will be the gradient of the function at point 3. Okay, so evaluating the gradient of the straight line, I can say that the rise is 1 and run is 1. You see in the graph, this is the rise and this is run. So rise is 1 unit, run is 1 unit, and it is in the positive direction. So gradient for this straight line from 2 to 6 is 1. So f dash 3 is also plus 1. So f dash 3 is just 1. Now need to evaluate g3. So according to the definition, it is basically the integral from 0 to 3 of the function fx. Right? Meaning finding out the area of the function, area bounded by the function with the x-axis, right? This is the definite integral from 0 to 3. So as you can see in the graph only, because how I can use the graph, because the functions, all these lines are straight lines, there is no curve involved, so there is no need to integrate this, right? We can just evaluate the areas. Now from 0 to 3, from 0 to this plus 1, the area is above the x-axis, so this area is positive, right? And as you can see that these two triangles are congruent, because here the rise is 1 and the rise is 3 and run is 1. Again in this, rise is 4 and run is 1. Basically this is also 4. So rise and run both the triangles are equal. So we can say that these two triangles are congruent. So whatever is the area above the x-axis, the same area we'll find below the x-axis, and when we integrate these two, they all will vanish, right? So integral of the function g from 0 to 2 is 0. Okay, so I can write this as from 0 to 2 fx dx plus integral from 2 to 3 fx dx. Okay, this value is 0. Now the thing is, you need to evaluate the area of this trapezium from 0 to 3. Okay, this trapezium. Now area of trapezium is half sum of parallel sides. Half sum of parallel sides. Parallel sides mean this length is 4 units, this length is 3 units. So this is 4 plus 3, and height meaning this length is 1 unit, so it is 1. And remember the area is below the x-axis, so it will be negative. Okay, so g3 is basically minus 7 by 2. Now we have g3 also, we have f dash 3 also. We put both these values in this equation, not here, here, right? So f dash 3, let me use the other line, right? So we have p dash 3 is equal to 9, which was f3 into f3, plus f dash 3 is 1 into minus 7 by 2. So this is basically 18 minus 7 by 2, which is 11 by 2. This is the answer for the second part. Okay, just see how beautifully the question is framed. Why I'm saying this? Because there is no need to evaluate the equation for the straight lines, and areas also are given in such a way that one area is exactly equal to the area below the x-axis, so they all get vanished, right? And here we have area of trapezium also, which is involved here, right? So all the concepts of areas, all the concepts of definite integrals, they are being tested here. Okay, this was B part. We have some two parts also. Okay, now in the C part it says evaluate this limit from of gx upon x square minus 2x. Now whenever we start evaluating limits, the first thing that comes in our mind is whether it is forming a 0 by 0 form. As you can see very clearly that in the denominator, if I put x equal to 2, this becomes 4, this becomes 4. So denominator is basically coming out to be 0. So we need to test whether this g2, this g2 is coming out to be 0 or not, right? Then we can say that it is a 0 by 0 form, and then we will apply the Hopital rule, right? So now G2, as in the previous question, just see how the questions are read. There is no need to evaluate separately, although you can find out very easily, because 0 to 2, between these 2 points, I said earlier in the previous part that the area above the x-axis is equal to the area below the x-axis. So from 0 to 2, G2 is 0. Okay, so this is coming out to be 0 by 0 form. So applying the Hopital rule, right, what it says that it will be equal to limit x tends to 2 g dash 2 over derivative of the denominator, which is 2x minus 2. Now this g dash 2 is basically the value of the function at 2, because derivative of gx is equal to fx. So this is 2x minus 2, limit x tends to 2. Now f2, look at the graph. This is the 2 value, and at x2 we have the value of function as minus 4. So this is minus 4 into 2 into 2 minus 2, which is 4 minus 2 is 2. So it is minus 2. So limit of this function is coming out to be minus 2. Again, although we are evaluating a different concepts, different in the sense that in the first two part we integrated, then we applied derivative, but within that derivative B part there was information which was hidden, or which is used in the next part, that gx is g2 is basically 0. Okay, and the last part says that find the average rate of change of g on the interval minus 4 to 2. We will deal the second part later on. First, let us understand the average rate of change. Average rate of change meaning that if suppose this is a function, this is the initial point denoted by IP, and this is the final point denoted by FP, right? Average rate of change is basically finding out the rise and run of the final point with the initial point, no matter how the curve is behaving between the points. Okay, so it is the average rate, and what is the instantaneous rate is basically the gradient at each and every point, right? And this is how we this is based basically on the fundamental first principle of derivative, when average rate is approaching towards the instantaneous rate. Okay, so average rate is, in the context of the question, is the value of g at the final point, value of the function at the final point. Final point is 2, minus value of the function at initial point, which is minus 4, divided by final point minus initial point. This is the average rate of change of the function g. How the function is changing between minus 4 and 2. So just join the initial with the final point and evaluate this. Now g2, again it is 0 from 0 to 2, right? Minus g of minus 4, meaning integral of 0 to minus 4 fx dx divided by 6. Now changing this minus sign to positive sign, I can interchange the limits from minus 4 to 0 and change this positive sign. Change this negative to positive sign. So it is basically 1 by 6 I am taking outside, integral of fx dx from minus 4 to 0. Now again, integral of fx, meaning finding out the area of the curve between minus 4 to 0, right? Again we look at the curve. This is our point minus 4, this is point 0, so this area we need to find out. It is not a regular type of a quadrilateral, right? So we need to break this into two. How we can do this? I can see that there is one triangle before minus 2 and there is a trapezium after minus 2. Okay, so area of this triangle is 1 by 6 as it is. Area of this triangle is half, base is 2, this length is 2 and height is 6. Okay, and plus half area of trapezium, which is half sum of parallel side. Parallel side meaning 6 plus 4 is 10, and again the height of the trapezium is 2, right? So this is equal to 1 by 6 into 2 gets cancelled with this. This is 6 plus 10. So this is 16 by 6 or 8 by 3 units, right? So this is the average rate of change of g in the interval minus 4 to 2. By 8 by 3 units, function g is changing. Now, in the second part, it says, does the mean value theorem guarantee a value c between the open interval minus 4 to 2, for which g dash c is equal to the average rate of change? Now, this is the average rate of change of the function between minus 4 to plus 2. But does the mean value theorem guarantee that there will be a point c within the open interval minus 4 and 2, wherein means at the point c the instantaneous rate, which is g dash c, is equal to average rate. So basically this is the statement of mean value theorem in the context of the question. Okay, what mean value theorem says, that the average rate of change is equal to the instantaneous rate at least a single point if the original function is continuous and differentiable in the open interval. If a function fx is continuous in the closed interval and it is differentiable in the open interval, then you will find a point c where the gradient of the chord, meaning the function is written, meaning the concept is right in front of you, at this instantaneous rate will be equal to the average rate. You will find a point within the interval at which the gradient of the tangent is parallel to the gradient, is equal to the gradient of the chord. This is the mean value theorem. So answer is yes, it guarantees. How I can say that it guarantees? Because the function, as you can see, is continuous between the intervals minus 4 and 2, and it is also differentiable within the open interval, right? That's why it says between the open interval minus 4 to 2. Had this interval not been given to you and the question remains the same, does the mean value theorem guarantee a value c between the closed interval minus 4 and 2, then the answer will be no, it does not guarantee. Why? Because in the closed interval at minus 4 and 2, function won't be differentiable, right, at the corner points. So since the intervals have been given as open, now the function is differentiable between all the points between minus 4 and 2. Hence, mean value theorem guarantees or is applicable in this question. Okay, So this was the question that I find very interesting from AP Calculus, and that's all for today. See you in the next video, very interesting video, and I will be uploading some more videos on AP Calculus. Just write any comment in the comment section on whatever topic you want to have some video. Take care. Bye bye. Good night.